I've got our laws for multiplying and dividing surds written here. It's really just a couple of simple ones, particularly for multiplying. It's very straightforward. For dividing, there's a couple of different ways we can present things. But the first thing is if I have root A multiplied by root A, well, that is just one thing multiplied by itself, which becomes root A squared. The other way I could write that here is to say root A all squared. But the ultimate thing there is, if I multiply two things, that's the same as squaring it, which means that undoes that, or is the inverse of that square root symbol. So that gives me just plain old A. And that leads to root A multiplied by root B, which is root of AB. If you'd imagine I had root 3 times root 5, well, that is just root 15. A divided by root B, well, we can straight away rewrite that as a fraction, which is root A over root B, which means I can turn that into the square root of A over B as a whole thing. Now that can work in both ways there. If we want to simplify a fraction to make the surd easier, or if we want to split the fraction up into its top and bottom part and take the square root individually. We'll look at a couple of examples. We've got a few examples here of how we might multiply and divide surds. Let's have a look at the first one. Well, we've got root 5 multiplied by root 2. Well, very simple answer. That becomes the root of 5 times 2, which is root 10. And we always check with these to see whether there might be a way for me to simplify my result. Can I turn that into a square number and a prime number? Well, 5 and 2 are both prime numbers, so there's nowhere I can go with root 10, so that's just my final answer. Though, I can rewrite that as the square root of 50. That's pretty straightforward. But if I have a look at that, that's actually 25 times 2. So it's root 25 times root 2. I've actually combined them together so that I can split them up again differently. And I can call that one 5 root 2. Now what we actually could have done from the start is turn that root 10 into root 5 times root 2. And we're multiplying them all. And if we have root 5 times root 5, well, that's the first rule that I started with, which was root 5 times root 5 is just plain old 5, which gives me 5 times root 2, or a final answer of 5 root 2. They are exactly the same way of getting to the same answer, just done in a slightly different order. Kind of like we have here for our third example, which is root 3 times 2 root 3. Well, this is just 2 times root 3 squared. Now, I didn't have to rewrite it that way. I could go write that as 2 root 9 if you'd like, which is just 2 times 3, which is 6. Okay. The main thing is we've got two things multiplying each other that are the same, root 3 times root 3. That's just going to give me 3. Okay. However you want to cut that, that gives me 2 times 3, which is 6. Problems here. Well, in my first example, I can take my fraction and I can split that up. Okay, I can turn that root of 25 over 2, the whole thing being square rooted, I can turn that into the root of 25 over the root of 2, which gives me, well, root 25 is 5, so my answer is 5 over root 2. And that's absolutely fine as an answer there. We've got our surd, or our irrational part on the bottom in our denominator, which we'll look at in a couple of lessons' time, how we might deal with that differently as well. Our second example, if I have a look at this, I can turn my two surds into a single surd by saying that's the same as root 18 over root 2. Or I can turn that into the root of 18 over 2, which becomes, well, 18 over 2, and just to be clear, that whole thing is under the square root, the radical there. 18 over 2 is 9, so this is just root 9, which is 3. Another way I could have gotten here is to simplify root 18 from the start, which would have given me root 18 becoming root 9 times root 2. So that would have given me root 9 times root 2 is 3 root 2 divided by root 2. Well, that's exactly the same as like saying 3x over x, which would have just given me 3 straight away as well. Either way, we do end up with the same answer. And again, it's a slightly different way to do the exact same thing to get to the same place. So when we're multiplying, I can put those surds together. I can just multiply those bases, and I can multiply the coefficient throughout the front as well. And if I'm dividing surds, I can write them as a single division, or I can split them up into two different surds, depending on how I want to go about this and what's most beneficial for me. I hope this has been helpful.